In this video, we will be learning about a formula which is helpful for computing, for calculating the exterior angle of a regular polygon. A polygon means the figures that you're seeing on the screen are examples of polygons. So a polygon is basically a closed figure, but that figure needs to be made only and only by joining straight lines. So the first figure which you see here is a triangle. It's consisting of three sides, so you can call it a polygon also. The second figure is also a polygon. It is a four-sided polygon. This is a five-sided polygon, and the fourth figure you see here is also a polygon. It is a six-sided polygon. Now, if the length of every side is going to be equal, then we call it a regular polygon. So for example, you talk of an equilateral triangle. In an equilateral triangle, every side has the same length. So if this length would be 10, even these two lengths are going to be 10. So an equilateral triangle is called as a regular polygon, whereas if you take a right angle triangle, then the length of every side will not be equal. So this is not a regular polygon, whereas an equilateral triangle, yes, it is a regular polygon. So in short, a regular polygon means a closed figure made by joining only straight lines, and the length of every side is going to be equal. Now for a regular polygon, the measure of its exterior angle, the measure of its every exterior angle is given by the formula 360 degrees upon n, where n represents the number of sides of that polygon. So for example, take that equilateral triangle only. If I go for 360 upon n, equilateral triangle means it has three sides. 360 upon n will give me 120. So this exterior angle here is going to be of measure 120 degrees. I used to often get confused with the fact that this formula would give me the exterior angle or the interior angle. So I would always try it out for an equilateral triangle. That is, I would go for 360 upon 3. It would give me 120, and that is how I would convince myself that yes, this formula was giving me the measure of exterior angle. Now say for example, what if you want the interior angle? You know that the exterior angle plus the interior angle, the total will be 180. Once you know what the exterior angle is, subtract that value from 180 and you will get the measure of interior angle. Okay, so with that formula you can compute the exterior angle of any polygon. Let's try it out for a square. A square means it is a four-sided figure and the length of every side is going to be the same. So for a square, the measure of every exterior angle would be 360 degrees divided by 4, which is equal to 90 degrees. And yeah, you can see it very well from the diagram that the exterior angle here is 90 degrees, and the interior angle would then be 180 minus 90, which is again 90 degrees. What if I talk of a pentagon? A pentagon is a five-sided figure. So the measure of this exterior angle, well, from the figure we can see that it is acute. Let's check by the formula whether we are getting an acute angle or no. So 360 degrees divided by 5, and we get what? We get 72 degrees. Yeah, so 72 degrees is the measure of the exterior angle for a pentagon, and yes, it is an acute angle. The interior angle would be 108 degrees. Keep in mind we are talking of a regular pentagon, so the length of every side is the same. Okay, for a hexagon, septagon, octagon, you can compute it by yourself. There's one more interesting point about this formula which I would like to discuss, after which we will take a few examples. So say for example, you take an equilateral triangle only. The measure of exterior angle which you got was 120 degrees. Now say for example, I take the center of this equilateral triangle and I am joining that center with the endpoints of any two sides. So I am drawing this line and I am drawing this line. The angle which you get in the middle here, this angle will also be equal to 360 divided by n. So even this angle for an equilateral triangle, that middle angle is going to be equal to 120 degrees. What if you take a square? Say for example, you take a square and you repeat the process. That is, you take the center and you join that center with the endpoints of any particular side like this. The angle in the middle which you get will be given by the same very formula, that is 360 upon n. So for a square, that middle angle which I have drawn here is going to be of measure equal to 90 degrees. What if I take a hexagon? So if I take a hexagon, a regular hexagon, I take the center and I am joining the endpoints of any particular side from the center. So let's take this side. I have joined the endpoints with the center. The angle which I am getting in the middle here, this will be 360 upon n. For a hexagon, n will be 6. So this angle will be 360 upon 6, that is equal to 60 degrees. So that is yet another important property about this particular formula. And having known this property, let's go ahead with a few examples. So we have find the degree and radian measure of the exterior and interior angle of a regular pentagon. Pentagon means 5 sides. So the exterior angle would be 360 upon 5, which is equal to 72 degrees. Interior angle is 72. I'm so sorry. The exterior angle is 72 and the interior angle would be 180 minus 72, that is 108 degrees. To convert these angles into radians, what we do is we multiply them with pi by 180. 72 degrees into pi upon 180. So when you multiply it with pi by 180, the angle gets converted to radians. And we can divide it with 36. So 36 2s are, 36 5s are, and the interior angle is 2 pi by 5. Okay, so the exterior angle is 2 pi by 5 radians, and if we convert 108 from degrees to radians, that would be 108 into pi upon 180. 36 into 3, 108. 36 into 5 is 180. So we have the measure of interior angle as 3 pi by 5 radians. Okay, that is the measure of interior and exterior angle for a pentagon. Let's go ahead with the same calculation for a hexagon. Hexagon means it will have 6 sides. The exterior angle will be 360 divided by 6, that is 60 degrees, the exterior angle, and the interior angle would be 180 minus 60, that is 120 degrees. Now, if you know how to convert that angle from degrees to radians and that entire thing, you must be knowing that 60 degrees is pi by 3 radians. And if 60 is pi by 3, we know that 120 will be 2 into 60. But because 60 was pi by 3, we can write 120 as 2 times pi by 3. Okay, so that's the radian measure for interior and exterior angle of a regular hexagon. The interior being 120 and the exterior being 60. Let's go ahead with the next one, that is a septagon. For a septagon, you wouldn't get an exact integer value because septagon would mean 7 sides. The exterior angle would be 360 degrees divided by 7. 360 is not a perfect multiple of 7. So you can find it in decimals if you want to, or you can leave it the way it is. And the interior angle would be 180 degrees minus 360 degrees divided by 7. I will leave it here only. Of course, you can convert it into radians. Okay, let's convert it. 360 upon 7 into pi upon 180. So 180 and 360 will get cancelled, giving you 2 pi by 7. Okay, and the interior angle would be 180 is pi minus 360 is 2 pi divided by 7. So I guess when you subtract them, you are going to get what? A 5 pi by 7. Okay, so these are the measures of exterior and interior angle of a regular septagon. Let's take one last polygon and then we can end this video. Octagon. So octagon would mean 8 sides and the exterior angle would be what? 360 degrees divided by 8. That would be 45 degrees. And in radians, this is pi by 4. So the exterior angle is 45. So the interior angle would be 180 minus 45. That is 135 degrees. Now we know that 135 is basically 45 into 3. In radians, 45 was pi by 4. So 135 is basically 45 into 3. So 135 in radians would be 3 pi by 4 radians. 3 times 45, that is 3 times pi by 4. Okay, so that's the radian and degree measure of the exterior angle and the interior angle for a regular octagon. So this is where I'm done with this video. I hope whatever I've discussed has been somewhere helpful to you in your preparations. Thank you for watching.